1810 in Guebwiller in Alsace, Nicolas Schlumberger built a textile mill that would prosper throughout the 19th century. His sons and grandsons were set to have rewarding industrial careers in the firm. Conrad and Marcel Schlumberger, two of Nicolas' grandsons, would also have joined the family business had their homeland not been occupied by the Prussians, and had their father, Paul Schlumberger, not handed down his love of science to them. Paul Schlumberger's 5 sons all eventually left Alsace, one after the other. Conrad went to Paris in 1893. He entered École Polytechnique, graduated with honors, and continued his studies at the prestigious École des Mines. A sensitive, humanitarian, almost mystical person, Conrad was led by his ideals to become a physicist. He was appointed professor of physics at École des Mines at the young age of 29. Conrad's brother, Marcel, 6 years his junior, had quite a different personality. A born inventor, Marcel was interested in everything that had to do with mechanics. He also moved to Paris and entered École Centrale to become an engineer. Paris, 1910. Marcel worked in the mining industry with his father-in-law. At the same time, Conrad was also focused on problems concerning mine prospecting, but his approach was more scientific. He imagined exploring the Earth's subsurface by means of electricity. Early 1911, in the cellars of École des Mines, Conrad moved from theory to practice. In a copper bathtub borrowed from his wife, he recreated various Earth models in which he placed ore samples. Running an electric current through these models, he measured its flow and recorded the equipotential curves. These experiments would confirm his intuition. Distortion of the curves indicated the presence of the ore samples. In the summer of 1912, at the family estate at Val-Richer in Normandy, Conrad took his first measurements in the field. He would later extend his experiments to other regions in France. The outbreak of World War I interrupted his experiments. While Conrad was mobilized as an artillery officer, Marcel directed his passion for mechanics to perfecting armored tank turrets. Once peace was restored, Conrad decided to resume his experiments. Marcel convinced Conrad to apply his electrical prospecting methods to the mining industry as a commercial undertaking. Their father, Paul, promised to finance their venture. He wrote, "The sums I undertake to supply my sons with are my contribution to a work that is primarily scientific and secondarily practical, and which I consider of great importance." Marcel will bring to Conrad his remarkable ability as an engineer and his common sense. Conrad, on the other hand, will be the man of science. I will support them. United in a common goal by their father, the two men formed an inseparable team. Paris, late 1919. Beside the esplanade of the Invalides, the two brothers started a small company which came to be known as the Société de Prospection Électrique, the crucible from which one of the most spectacular industrial enterprises of the century would emerge. Conrad, a physicist mainly interested in pure research, established the principles of a new science called geophysics. Marcel, with his extraordinary creativity, developed tools that would allow them to supply this new science. The two brothers began collaborating with a few men of high scientific and technical caliber. Among these first collaborators were Pierre Baron, Jacques Galois, and Eugène Leonardon, who would later on play major roles in the company's development in the United States. Wandering the French countryside in an old van through forest and fields, each engineer took on a role. One planted the electrodes that emitted the current, another pulled out the cables, while the third took the measurements. However, the equipotential curve method quickly proved to be too limited in its applicability. The two brothers took a decisive step in the development of the electrical prospecting method by introducing a new measurement, the apparent resistivity of the Earth. The apparent resistivity tells the degree of resistance of the Earth to an electric current. In the spring of 1927, in an attempt to find out more about the resistivity of deeper strata, Conrad and Marcel came up with the idea of taking resistivity measurements inside a borehole. They went to Pechelbronn in Alsace to experiment in a well in a small oil field. Henri Dole, Conrad's son-in-law and fellow graduate of both Polytechnique and École des Mines, had recently joined the company. He was put in charge of carrying out the first experiment in the 1650-foot well with improvised equipment. Dole, assisted by Roger Jost and Charles Chebly, undertook the experiment. They lowered a device for taking electrical measurements, called a sonde, into the well. When the sonde reached the bottom of the well, an electric current was sent to the lowest of the instrument's 3 electrodes. The current spread to the surrounding layers of earth. The current's intensity was measured by the middle electrode, then by a third electrode placed slightly above the middle one. The difference in electric potential indicated the apparent resistivity of the earth. By repeating the operation while pulling the sonde up the wellbore in meter-long intervals, the resistivity of the various layers of earth can be recorded. The graphic representation of these measurements, which is called a log, became the primary reference document for the oil industry.